Good morning, afternoon, noon, evening. We are going to discuss something about ketosis. There is excessive generation of ketone bodies, acetoacetate, beta-hydroxybutyrate, acetone in the liver. And the two major conditions are diabetes and starvation. Mainly it is the type 1 diabetes. Both are low insulin glucagon ratio condition, means insulin level falls. Ketosis or excess ketone bodies generation occurs in two stages. In both the conditions, first there is a rise in the free fatty acid level in the bloodstream. Free fatty acid is degraded subsequently to acetyl coenzyme A, which all of you know is a precursor molecule for ketone bodies. So this is what happens. So we are going to discuss in two stages. First, why free fatty acid level rises, and then we will see that why this free fatty acid excess level, how it leads to ketone bodies generation. Now here we have shown in this figure uh, an adipocyte. All of you know that source and determinant of ketone bodies in the blood are uh, source and determinant of free fatty acids in the blood are the triacylglycerols present in the adipocytes. There is a dynamic steady state. Triacylglycerols are continually being synthesized with the help of an enzyme called acyltransferase, abbreviated as E1, and they are continually being degraded to form glycerol and fatty acids. The enzyme here is hormone-sensitive lipase. Normally, synthesis and degradation. Degradation is called lipolysis, and synthesis of triglyceride, their rates are equal to each other. So rates of both these synthetic and degradative pathway are equal to each other in a normal condition. So whatever fatty acids are produced, they are reactivated to fatty acyl coenzyme A, which again go for synthesis of the triacylglycerol. That is what happens in a normal individual. But in diabetes, starvation, the low insulin condition, what happens, we are going to see. An important point here is that this enzyme, acyltransferase, is stimulated by insulin. And this enzyme, hormone-sensitive lipase, this is inhibited by insulin. So in low insulin state, what will happen? Activity of E1 will decrease and activity of E2 will increase because it is inhibited by insulin. तो कम इंसुलिन होगा तो इसकी एक्टिविटी बढ़ जाएगी. So degradative enzyme activity is much more than synthetic enzyme activity, as a result of which rate of lipolysis will now increase. It will exceed the rate of synthesis. So more lipolysis is occurring compared to what synthesis is occurring. In other words, more fatty acids are generated than can be reutilized, than can be recycled. So therefore, the excessive fatty acids, they leak out into the blood circulation. So that leads to the first part of the story. The free fatty acid in the bloodstream are going to rise. And as you know, that fatty acids, after they are degraded, they are converted to acetyl coenzyme A. The second part, why free fatty acids are converted to ketone bodies. Let me clarify what I want to say. The acetyl coenzyme A can go for a number of pathways. It can go not only for ketone body synthesis, it can also be channelized into the TCA cycle. Acetyl coenzyme A is also a precursor molecule for fatty acid synthesis. The process is called lipogenesis. Acetyl coenzyme A can also form cholesterologenesis. So ketone bodies are not the only pathway where acetyl coenzyme A can be channelized, can move into. So why don't they enter the TCA cycle and fatty acid synthesis, etc.? We are going to very quickly see. As you all know that the first intermediate of TCA cycle is oxaloacetate, concentration of which is an important determinant which sets the pace of TCA cycle. Now, in diabetes and starvation, the low insulin states, oxaloacetate is channelized to gluconeogenesis. So oxaloacetate will move into gluconeogenesis to form glucose. So therefore, concentration of oxaloacetate will fall. And as we said, it's an important determinant of setting pace of TCA cycle. So TCA will decrease. And moreover, insulin is a stimulator of several enzymes of TCA cycle. So this pathway is impaired or halted to a considerable extent. Why this fatty acid synthesis? This pathway is also decreased. As you know, the regulatory enzyme for this pathway is a carboxylase, acetyl coenzyme A carboxylase. इसके दो important stimulators हैं. Number one, insulin is potent stimulator of carboxylase. So less insulin, carboxylase activity will fall. Another allosteric activator of this enzyme is citrate, the first intermediate of TCA cycle. So citrate concentration will also fall because as we saw, TCA is getting hampered. So therefore, carboxylase activity will further fall. So acetyl coenzyme A carboxylase, the rate limiting, the most important regulatory enzyme for fatty acid synthesis, the process called lipogenesis, it will fall. So therefore, acetyl coenzyme A will be prevented from entering into the pathway of lipogenesis. So what are the two pathways open? Ketone body synthesis and cholesterol synthesis. And indeed, acetyl coenzyme is channelized into these two pathways. So therefore, not only ketone body synthesis, but cholesterol synthesis also increases. But anyway, let us focus on it. Our main question was why excessive ketone bodies formation occurs. So this is the reason we have seen. So ketonemia, the increase in the ketone body concentration in the blood, and ketonuria. After it crosses certain limits, they start excreting in excessive quantities in the urine, ketonuria. Ketonemia plus ketonuria together, that is called ketosis. Thank you so much.